Please, can we start? This is module 1.2 of day 1 revision series, which is simple interest, compound interest, and time value of money. When it comes to this simple interest, compound interest, and time value of money, these simple interest and compound interest, you might have heard it in your earlier classes, lower classes, etc. things. So when it comes to this simple interest and compound interest, you might have heard the term or discussed the term in your earlier classes, 11th or 12th or any of your lower classes. But this time value of money is quite important when it comes to your CMA foundation, CMA intermediate, also in CMA final and in real life. So get it thorough now itself. The moment you get it thorough, you will be able to use it in your intermediate, final, whatever it may be. Whatever the professional course, whatever the financial subject or money related, money market subject you are discussing, this time value of money will help you to understand that valuation of any security, whatever it may be. Anywhere a rupee is involved, anywhere valuation is involved, you will get to know about this. You will be discussing this time value of money hereafter in your intermediate, final, whatever it may be. So this time value of money, this name is important till you complete the journey of CMA. You should know how to use this time value of money. The time value of money will come in the course of our class. Now, what is simple interest? What is simple interest? Is my voice audible in online? Hope it will be. So what's meant by simple interest? By the term, by the name itself, the interest is simple. By the name itself, interest is simple. What is meant by that simple? Right. Which means linear in nature. It's linear in nature. Sir, we are using some mathematical terms. Linear in nature it's not a big term. It's quite easy to understand. Remains constant in per unit and varies in total. This term remains constant in per unit and varies in total. I am 200% sure you will read this term once again in your intermediate. Once again in your intermediate. You will read this term once again in your intermediate with a different name. With a different name, different subject. Just the backbone of your CMA. Just a backbone. That subject and particularly that concept will be the backbone of your entire CMA journey. Which will be the core paper hereafter from your intermediate. Suspense. This one is suspense. Part 2, part 3, something like that. Now, let me take an example. If one chair cost 10 rupee, 2 chair cost, what's the cost of 2 chairs? 3 chairs, 100 chairs, 1000 rupees. Now, does the per unit value changes here? Whereas the total for 10 chairs, total cost for 10 chairs, total cost for 20 chairs, total cost for 30 chairs, it changes, right? This is what we call it as simple in nature. I will also give you an example which is not simple, which is not linear. I'm not getting much into the theoretical concept of what is meant by linear, not getting much into it. It's a mathematical term. I'm just giving you an example what is meant by simple or what is meant by linear in nature. Say you are taking a room for rent. If it is occupied by one person and the room rent is 10,000, what's the per head value? 10,000, right? What's the per head share? 10,000. If it is occupied by 2%, what's the per head value? 5,000. Does the per unit value changes? Yes. Does the total changes? No, it remains constant. It remains constant, which means it's not simple. It's not linear. Irrespective of the term you add, the total will change with a constant growth. The total will change with a constant growth. This is what we call it as simple in nature or linear in nature. As I mentioned, I don't want to get much into this, the explanation of what is meant by linear, what is meant by simple. Just have it as it is. The interest for 1 year, first year will be equal to the interest for second year, will be equal to the interest for third year, and goes on. When you add all of this, it will vary. But for each year, it remains constant or part of the year. Sir, what do you mean by part of the year? If 1 year interest is equal to 1000 rupees, what can you say about half a year interest? 500. What can you say about quarter year interest? 250. You will be able to reduce it. You will be able to rationalize it, right? This is also another explanation of what is meant by linear. You will be able to rationalize it. So, what's the formula for simple interest? Simple interest will be equal to an amount. You are depositing an amount or you are lending an amount. We call that amount as principal. You call that amount as principal. You are lending that amount for n number of years. At the interest rate of interest of, you don't know what is the rate of interest is, let me call it as R percentage. It's nothing but PNR by 100. I'm writing that R percentage as R by 100. If it is for 2 years, P into 2 into R percentage or R by 100. If it is for 3 years, P into 3 into R percentage. If it is for 4 years, P into 4. So, the year only changes, whereas principal and rate of interest remains constant. What is the one and only change here? What is the one and only part which is changing? Years. So, the one and only variable terms, years and total. Others remains constant. Others remains constant. This is the formula for simple interest. Now, you will get a term called amount, which is the final maturity value, which means principal plus simple interest. P multiplied with 1 plus NR by 100. This is the formula for amount. Clear? Clear? Clear with it? Now, sir, is there any other concept in simple interest? Actually, no. Conceptually, it's over. Conceptually, it's over. I'm asking you a question. You will be getting the same question with a different number. You will be given with amount for 2 years. You will be given with, okay, everyone clear with what is meant by simple interest? How to compute simple interest? How to compute amount, etc. things. If the year itself is not in full whole number, reduce it into rational number. If it is 6.5, write it as 6.5. If it is 6 years and 3 months, write it as 6.25. So, if it is for 1 month or 2 month or 3 month or 12 month will be equal to, the sum of each month will be equal to 1 year. That's what I have mentioned it as rationalizing one. It is like we will be able to rationalize the terms or the years or the months or the time. Now, you will be given with a principal amount which is deposited at a specific rate of interest will give you or fetch you a maturity value at this period, say T1, and if withdrawn at some later period, it will fetch you an amount of T2. It will fetch you an amount of T2. Now, what can you say about the difference between these two terms? What can you say about the difference between these two terms? The maturity amount at one time minus the maturity amount at another time. What can you say about it? It will be proportional to. It will be proportional to. I am writing it as T2. I am writing it as T2 and here it is a T1. Just to avoid the negative sign. Just to avoid the negative sign. Now. Which will be proportional to the difference between the years. The difference between the years. Sir, proportional to. You are mentioning it as proportional to. What is the proportionality constant? If x is proportional to y, you can write it as x equal to ky. That's what we call it as proportionality constant. This k is what we call it as proportionality constant. K is equal to the ratio between x and y. K is nothing but the ratio between x and y. Now, what is the proportionality constant here? Here, k is nothing but simple interest for 1 year. K is nothing but simple interest for 1 year. So, actually we are discussing what? Simple interest and compound interest. But we are taking the concepts or taking the help from ratio, proportion and variations. Yes or no? We are taking the help from ratio, proportions and variations. This is how you should interact with your intellect. What do you know? You know ratio. You understood ratio. With the help of ratio, you understood variations and proportion. With the help of these three, you are going to manipulate these three to understand simple interest. Next, I am going to manipulate simple interest to understand compound interest. Next, I will be manipulating compound interest to understand time value of money. Next, another manipulating time value of money to understand intermediate one subject. Let's discuss in our intermediate revision class. Coming back. The K is nothing but, the proportionality constant is nothing but simple interest for 1 year. What I mentioned earlier, the interest remains constant for each year. So can I call it as, with the right item, can I call it as a constant one? Yes, it is a constant one. This is a constant one. Yes or no? Each year simple interest remains constant. Or will there be a variation between interest for 1 year, interest for second year, interest for third year? Will there be a variation? No. If there is a variation, we call it as compound interest. If there is a variation, we call it as compound interest. Unless the principal or unless the rate of interest changes, the simple interest doesn't change. Clear? So, if you are given with maturity amount for two different periods, the difference between those two periods will be proportional to, the difference between amount for those two periods will be proportional to difference between those two years. So, if you are given with amount at the end of 7.5 years, and if you are given with amount at the end of 4 years, amount, not the simple interest, amount, that will be equal to, proportional to, I am writing it as equal to what? Difference between 7.5 minus 4 times simple interest for 1 year. Clear? Clear? So, will you be able to solve the problem? Similar type of problem? Yes or no? This is the one and only case where you will be tested in simple interest. This is the one and only major area where you will be tested in simple interest. Proceeding further. These were the things when it comes to simple interest. Let's have a quick revision. What is meant by simple interest? With the name itself, it's simple in nature. With the name itself, it's simple in nature and linear. What is meant by the term simple linear? Which means you will be able to rationalize the interest for 1 year, 1 month, 1 day, and etc. Now, what is the main thing you have? What, 3 things you have to note. Simple interest, formula for simple interest. P multiplied with principal multiplied with number of years multiplied with rate of interest, ROI. Foundation, with respect to foundation, ROI represents rate of interest. When it comes to intermediate or final, we will be discussing it in one another name called return of investment. Okay, இப்போதைக்கு have a note, it is only rate of interest. Anywhere, by mistake, if I represent return on investment, it represents rate of interest only. Now, what the third most important thing, proportionality constant. The difference between amounts of two, maturity value of two time period will be proportional to difference between the time multiplied with simple interest, not proportionality, equal to difference between the time multiplied with simple interest for 1 year. Clear till this? Can we proceed for few sums? If the simple interest on certain sum for 15 months at 7.5 per annum, that is the ROI, rate of interest, exceeds the simple interest on the same for 8 months at 12.5% per annum by rupees 32.50. What is the sum? Such a big question. I am sure you will be given these kind of questions in examination, as if it will project you in a manner difficult to understand. But mathematics, when it comes to mathematics, when you are having a big question, be happy you are having that as much as information needed. When you are having a big question, take it for granted you will be getting as much of information needed. So never get worried about big questions. Now, the simple interest on sum for 15 months. So we will be having 2 years. That is 2 period, 15 months and 8 months. What is the rate of interest? What is the rate of interest? 7.5. How will you write 7.5? Half is 0.5. Hope you have heard about mixed fraction in your lower classes. Yes or no? What is meant by mixed fraction? QR by D. Quotient remainder divided by dividend. Divisor. You will multiply the Q with the D and add it with the R, that is numerator, divided by the denominator. This is how you will write. So, if I do the same, how it will be? 7 into 2 plus, right? Sir, why you are making these much expansions? 7 1 by 2 is nothing but 7.5, right? I'm just telling this because you should get an understanding. Any mixed fraction can be written as like this. What you mentioned? 7.5 is nothing but 7 plus 0.5. Yes or no? So any mixed fraction QR by D can be written as Q plus R by D. You will be taught in your lower class. It should be written as an improper fraction as if Q into D plus R by D. It's not exact always. You can write it as Q plus R by D. Any mixed fraction is equal to this thing only. Here 7, 1 by 2 is in mixed fraction. You can write it as 7 plus 1 by 2. That thing you know. If I have 3, 4 by 3. What does it mean? What does it mean? Or 3, 3 by 4. What does it mean? It's a mixed fraction. You will convert it into an improper fraction. Not needed. Just write it as 3 plus 4 by 3. Done. Done. Enough. So you should be familiar with how to convert a mixed fraction into a not an improper fraction. How to convert a mixed fraction into a decimal number. Just write what is Q plus take the remaining, divide it, write it in decimal. That's it. So what is the rate of interest here? 7.5. What is the rate of interest here? 12.5. Yes or no? It's 12.5. Now comes the major part. The simple interest. So here you will be getting one simple interest. Here you will be getting another simple interest. The simple interest on a sum. N2 R2 by 100 on a sum for 15 months at 7.5% per annum exceeds it's a positive term. Upper which one is bigger? The first given one is bigger one. Exceeds the simple interest on the same for 8 months at 12.5% per annum by 32.5, which means the bigger one minus, okay, A is the bigger one. A is the bigger one. Exceeds by certain amount they have mentioned, right? How can you write A minus B is equal to 32.5? A minus B is equal to 32.5. So how can you curate it once again? P multiplied with 7.5 by 100 into number of years is 15 months. How can you write 15 months now? How can you write 15 months? N is years, right? 7.5 per annum. Per annum. So the year should be in multiples of number of terms should be in multiples of years, not in months. How you got it? How you got it? 12 plus 3. 12 plus 3. You have to convert it into years, divided with 12. 1 plus 3 by 12. Again a mixed fraction. Again a mixed fraction. 1 by 4. 1 by 4. 1.25. It will be 1.25, yes or no? Into 1.25. Clear? Exceeds. So it's given at exceeds. What is the simple interest for the second quantum, for the second portfolio? The principal remains same. over both the portfolios. P multiplied with, instead of 7.5, you will be writing it as 12.5. How can you write 8 months? How? Come again. Is it 8 by 12? Try to write it in years. Can I write this 8 by 12 as 8 months as 12 minus 4? 12 minus 4? 1 minus 1 by 3. Yes or no? 2 by 3. 0.67 is the right answer. I am not denying it. But you should be able to know how to write that 0.67 in fraction also. It's 2 by 3 only. It's 2 by 3. So I am writing it as 2 by 3. The difference between these two is 32.5. What can be the answer? That's the question. P is the common one. 7.5 into 1.25 by 100. What is 7.5 into 1.25? Put it in calculator. What's 7.5 into 1.25? 9.37 divided by 100 minus wait. 12.5 into 2, 25. 12.5 into 2 is 25 divided by 3, 8.333, right? It's 8.333 divided by 100 equal to 32.5. Others, you know how to solve it. Take the difference, divide it with 32.5, you will get principal. Clear? Clear? Can I proceed? Can I proceed? One similar problem. If the simple interest on 1400, wait, for 3 years is less than the simple interest on 1800 for same period. Upper you will be having two simple interest. Put the inequality as it is less than. Upper which is the lesser one? Is less. Right? So the lesser quantity is simple interest 1, greater quantity is simple interest 2. Lesser than the simple interest on 1800 for same time period by 80. Appo bigger one minus smaller one is equal to 80. Balance you know how to solve. Yes or no? Solve panna mudiyuma. You have principal. You have two principal. You have number of years. You have to find what is the rate of interest. Rate of interest, nothing is mentioned, so the rate of interest and the number of years remains same. Clear? Just the principal varies. Can I proceed? Can I move towards compound interest? Clear with simple interest, everyone? Yeah, you will be getting few problems. Find the principal, find the interest, find the time period. You will be asked to find what is P, what is N, what is R sometimes. Just rearrange the formula, you will get it. Here we have rearranged the formula, we got P. Yes or no? Similarly, we will be rearranging the formula to get R. Rearrange the formula to get n. That's it with simple interest. Majority of the questions will be like this only, and you will be tested only here. This is one important problem. The more like one and only important problem, important concept when it comes to simple interest. Can I proceed towards compound interest? Can I? Now, compound interest. From the term itself, you will get to know what is meant by compound interest. With no knowledge, so what is compound interest? What is simple interest? Interest is simple in nature. What is compound interest? Compound in nature. Interest will be compounding in nature. Yes or no? Interest will be compounding in nature. What is compounding in nature? What is meant by compounding? Exactly. Anyone mentioned? Exactly. Compounding, the term mentions addition, or more specifically inclusion. The mathematical word is inclusion. Compound is nothing but inclusion. Compound one. You are including a boundary to the area, right? To your house. Or you can also call it as, it can also be used to classify as separation, but not here. What is compounding? You are bringing something inside your space. You are bringing something inside your space, which means, say you have a principal, you are investing it at some rate of interest, some I percentage of interest. What can be the interest accumulated for 1 year? What can be the interest accumulated for 1 year? P into I percentage. Yes or no? P into I percentage. And what will be the amount at that year? At the end of that year, what will be the amount? P plus PI. Yes or no? I am just making P as a common one, so it will be P times 1 plus I. So this is the amount at the end of 1 year, right? Which will be the principal at the beginning of that year, beginning of next year. The amount at the end of 1 year will be the principal for the next year. Now, the interest will be calculated on this principal, not on this principal. The interest will be calculated on this principal, not on this principal. What can be the interest for that year? Interest 2 equal to P2 into I. Yes or no? P2 into I percentage. Yes or no? What is P2? What is P2? P into 1 plus I. Into I. Right? Right? What is the amount at the end of that year? P2 plus interest on that P2 will be P2 into I, which is P2 into 1 plus I. What is P2? P1 into 1 plus I. Again, you have to write this here. It will be 1 plus I. So, you will get P1 into 1 plus I the whole square. This is the amount at the end of second year. If I continue in this manner, what will be the amount I will be getting at the end of nth year? The same logic applies. P multiplied with the initial principal multiplied with 1 plus I the whole power n. This is the formula for amount. So what's the formula for amount in compound interest? P multiplied with 1 plus I the whole power n. In some nomenclatures it will be T. The number of years will be represented as T. Where this 1 plus I the whole power n, I call it as compounding factor. I call it as compounding factor. Clear? Clear? Any doubts? Now, what is the compound interest? We have found only the amount for compound interest. What is compound interest? Amount minus principal. That's it. Which is principal into 1 plus I the whole power n minus principal, which I can once again write it as 1 plus I the whole power n minus 1. That's it. That's it. Clear? Is this one clear? Now. 5 minutes. Let's close compound interest and go for a break. 5 minutes. Just pair another 5 minutes. There are certain banks. If you invest this day, say what is today? 15th of November. 14th November 2026, hopefully you will be in your intermediate. You will be preparing for your intermediate. You will be approaching your intermediate exam. Hopefully group 2. If you invest this day, at the end of 1 year, I will be giving this amount. If you lend me this amount for 1 year, if you lend me this principal for 1 year, say 1000 rupees for 1 year, on 14th November 5 p.m. I will give you interest 100 rupee. Okay. What if instead of 14th November I am withdrawing the amount, I am withdrawing my principal on 13th November. I am withdrawing my amount on 12th November. I am withdrawing my amount on 1st November. I am withdrawing my amount on April, 1st May. Differs, right? Will the bank say, no, you haven't invested it for 1 complete year, so I won't give a single penny? Bank has to give. Yes or no? So bank has started using, instead of per annum concept, they have started using half yearly concept. So we call it as interest compounded half yearly. Interest compounded half yearly. What does it mean? For every 6 months, the bank will pay you interest. So if P is the principal, what can be the interest? What can be the interest for half a year? P times I into 6 by 12. I am calling it as 1 by 2. Again, it's a ratio. 6 by 12 is a ratio. Yes or no? I am calling it as 1 by 2. So it will be P into I by 2. What can be the amount at the end of half year? Principal plus compound interest, which is P plus Pi by 2. P into 1 plus I by 2, which will be the interest at the end of 6 months. Now I need the interest at the end of 1 year. This will be compounded for another 6 months, right? This term will be compounded. This principal amount will be compounded for another 6 months. So interest at the end of 1 year will be P into 1 plus I by 2 into I by 2. Then what can you say about amount at the end of 1 year? P into 1 plus I by 2 into 1 plus I by 2. Yes or no? I call it as P into 1 plus I by 2 whole square. I am writing it as 2 into 1. This is for interest compounded half yearly. What if for every 3 months, bank is paying you interest? How many quarters do you have? 4 quarters. How many compounding terms you have? In half yearly, you had 2 compounding terms. When it comes to quarterly, you will be having 4 compounding terms. So, interest compounded quarterly. What can what can be the formula for amount? Principal multiplied with, if it is half yearly, you are dividing I by 2 and multiplying 2 towards the power. If it is for quarterly, it will be 1 plus I by 4 power 4n. Power 4n. Now, interest compounded quarterly பார்த்தாச்சு. அடுத்து monthly. Amount will be equal to principal multiplied with 1 plus I by 12 power 12n. Clear? Clear? With this, I am giving you a break. The upcoming session, we will be revising this compound interest once again. We will be discussing few sums, effective rate of interest, time value of money. 10:30 we will be completing, or at least 10:45 we will be completing time value of money. Another 1 hour for arithmetic progression, geometric progression, 20 minutes for left out topics. Few miscellaneous. It's around 10:35. Okay, let's continue from where we have stopped. A quick revision to compound interest. What is meant by compound interest? Interest which is not compounding in nature. Sorry. Interest which is compounding in nature. That is what we call it as compound interest. And unlike simple interest, it won't be linear in nature. So year on year, the value of compound interest, the year on year, the value of compound interest will keep on increasing, will keep on changing. It's not increasing actually, it keep on changing. Now what's the formula for amount in compound interest? Amount will be equal to principal multiplied with I plus 1 plus I the whole power n. And to find the compound interest term, specifically the compound interest term, you have to subtract amount and principal. You will be getting pure compound interest part. Then if the quotient represents, instead of interest being compounded yearly, if it is compounded half yearly, how can you compute amount? How can you compute amount? Amount will be equal to P multiplied with 1 plus, instead of I, you should replace it with I by 2, and instead of power n, you should replace it with power 2n. Similarly, for compounded quarterly, it should be, the compounding factor should be 1 plus I by 4 power 4n. For monthly, it will be 1 plus I by 12 power 12n. Now, one small concept. With that, we will be completing compound interest and proceed towards present value of money. Effective interest rate. Effective interest rate. What's this effective interest rate? Gavani, say there is a portfolio which contains 1000 rupees as principal, and the interest rate being 12%, compounded semi-annually. In this scenario, what can be the formula for amount? Will be equal to principal multiplied with 1 plus I by 2 power 2n, right? 1 plus I by 2 power 2n. Before proceeding it here, I would like to give you an introduction for indices. How can we manipulate the powers? Not physical powers, mental power. Power of a number. If you have a number, if you have a base number, and that base number raised to the power m, multiplied with the entire quantity, multiplied with same base, power raised to some other n different from m. some other number n different from m, then how can you write that number? A power m plus n and vice versa. And vice versa. Now, similarly, divided by a power n will be equal to a power m minus n. Without your permission, I have started the class. நீங்க லேட் பண்ற நேரம் நான் லேட் பண்ணிட்டே இருப்பேன். 1:15 ஆகும். Instead of product, I made a division here. Now similarly, if you have a power m, the whole thing raised to the power n. If you have a power m, whole thing raised to the power n, how can you write it? And vice versa. It's also equivalent to a power n the whole power m. What's a power 0? Anything to the power infinity. We don't know the answer, but anything to the power minus infinity will be 1 divided by that anything power infinity, which is 0. Anything power infinity is not in our scope. It's not in our scope. Keta theriyad. I don't know. Mujhe nahi malum. I don't know. I don't know in Telugu or Kannada or Malayalam. Being a pan-India video lecture, we have to do these things. So, I'm just using these indices concept here. I have 1 plus I by 2 the whole power 2, right? Which is the amount at the end of 1 year. Now, 1000 multiplied with 1 plus. என்ன வரும்? 1 plus decimal அல்ல, இதுவாவே fraction ஆவே 12 by 2. 12 by 2 it's enough. Okay, 12% by 2. 12% by 2. Power it will be 2 into 1, right? Power it will be 2 into 1. So it will be, what is 12% divided by 2? It's 6%. 1 plus 6% is 1.06. 1000 multiplied with 1.06 power. What's power 2?
1.1236.
The answer is 1000 multiplied with 1.12. Now, this answer will be the amount at the end of 1 year. Yes or no? Amount at the end of 1 year. Had the interest being 12% compounded half yearly. Right? Now, had the interest being compounded annually. Instead of half yearly, had the interest being compounded annually. ஒருவேளை annual component இருந்தா, what can be the interest rate? If instead of compounding semi-annually, if it is compounding annually, for every 1 year, the compounding will take place. In such scenario, what can be the interest? What can be the interest? That will be the effective interest rate. That will be effective interest rate, which is, I can write it as 1000 multiplied with 1 plus 0.1236, right? Which is 12.36 by 100. 12.36 by 100 power 1. Power 1. So the effective interest rate is 12.36%. So what's the concept hidden here? If you want to find the effective interest rate for any number of compounding, compounded half yearly, compounded quarterly, compounded monthly, compounded daily, whatever it may be, write the compounding factor as if Try to bring the compounding factor as if p multiplied with 1 plus something raised to the power n. That n is number of years. You don't need to multiply. If it is compounded half yearly, 2n. If it is compounded quarterly, it will be power will be 4n. If it is compounded monthly, power will be 12n. Bring it to power n. How to bring it to power n? In the scenario, I am just grouping this. Now the power will be 1, right? Now the power will be 1, yes or no? If it is for 3 years, it will be 2 into 3. There, till 2, if I am grouping it as one specific term, the remaining term will be having power 3, yes or no? The remaining will be left with 3. So the entire thing, in that entire thing, what is written next to that 1 plus? What is written next to that 1 plus will be your answer. Clear? How to find effective interest rate? Clear how to find effective interest rate? Now, let me give you a scenario. I'm just using this indices concepts. A power mn, I can write it as a power mn to n. Once again, I can write it as a power n the whole power m. I am using that concept here. So it will be power 2, the whole thing raised to the power 1 or number of years. The whole thing raised to the power number of years. Inside the term, you should rearrange it in a manner. It is equivalent to 1 plus something. 1 plus something. What I did here, I have rearranged it in a manner 1 plus 12% by 2 power 2. If I make a square, it will be 1, like if I rearrange it, it will be 1.06 square. But I need the power 1. But it is given in 2. Take square, execute the square. It will be power 1. Yes or no? So it will be 1.1236. Write it in form of 1 plus something. That 1 plus something will give you the interest rate. Clear? All of the majority of compound interest is over with this. Problems are being keta. Are you clear with how to solve this problem? That's it with compound interest. Same formula manipulations. You know the formula. You know how to deal with the formula, how to execute, how to approach, how to substitute. That's it. Now, the most important concept of time value of money and annuity. If you want to copy, kindly do it. Proceeding further. Attention, standard is school dispersed, etc. Please. Time value of money and annuity. The same example I am going to take, which I took for the regular class. Hope many of you have seen this small samosa. Chai Kings are famous. It's famous on Chai Kings. Those small samosa, putti samosa. Let me take the example of Chai King itself. One box. It cost around 20 rupees, right? Okay, let it be 20 rupees. How many pieces will you get? 4. 4. So, for 20 rupees, you are getting 4 pieces. Before COVID, that is, the customer before 6 years. before 6 years, for the same 20 rupees, how many paces you may expect? 8. A good answer? 8. Had the taste got different? Had the ingredients got different? Had the shape of samosa got different? Had the oil got different? Had any other unknown thing got different? Why? Why?
English and Sanskrit.
Here it will come a economics topic, inflation, which you will be discussing 3 or 4 days later. Second law, third law. Third only. Okay, another week. You will be discussing this in the next week or upcoming week. Mathematically, what is happening? I am changing the question. If I can get 4 pieces for 20, 1 piece, 5 rupees. For 1 rupee, quantify it. If for 20 rupees I am getting 4, Pani Puri story only. Na 10 rupees kudukren, 20 rupees. If for 10 rupees you can give 5 pieces of Pani Puri, can you give 10 pieces for 20? Right? Similarly, plate charges, etc., bowl charges, vegayan charges, etc. things he won't give. That's a different story. Now, if for 20 rupees I can get 4 pieces, then for 1 rupee, how many I can get? Point. So the value of 1 rupee is 0.2 in 2025. Similarly, 6 years back, for 1 rupee, how many I can get? 8 divided by 20. Point. This is 2019. அந்த காலம். This is 2019. கொஞ்சம் ஃபீல் பண்ணிக்கிறேன் ப்ளீஸ். Fine. What has changed? What has changed? Value of 1 rupee got changed. Value of 1 rupee got changed. Yes or no? This is what we call it as time value of money. How per rupee value changes over a period of time. This is what we will be discussing in present value and future value. Now, in order to have 1 rupee, in 2025, say this 1 rupee is the maturity amount for any investment you made in way back 2019. For that investment, one compounding factor will act, right, for 6 years, 1 plus I power 6. After adjusting that compounding factor only, you have got this 1 rupee. After adjusting that compounding factor, say 12% compounding factor, the normal average of 12% compounding factor. If any amount, or what is the amount I should have invested in 2019? What is the amount I should have invested in 2019 at a rate of interest 12% compound at 12% compound interest per annum, so that I will get 1 rupee now? My question is, what's the principal amount? What's the principal value I should have invested in way back 2019 at 12% compound interest to get a maturity amount of rupee 1 now? How will you compute? Let me take it as x multiplied with 1 plus 12 percentage, the whole power 6 up. 6, 8 la 6 will be equal to 1. Appa x என்னது 1 divided by 1 plus 12 percentage, right? 1 plus 12 percentage, right? We call it as present value factor. Present value factor of 1 rupee for 6 years. For 6 years at 12 percentage interest. At 12 percentage interest. This is what we call it as present value factor. This is what we call it as present value factor. This year is 2019. Assume we are in 2019. Assume we are in 2019. இந்த மாதிரி ஆன்லைன் கிளாஸ்லாம் இருக்காது, face to face classes. No phones, no mobile phones. That is Zoom meeting, Google Meet, அதெல்லாம் கிடையாது. No mobile phones. Only என்னது face to face. கிளாஸ் வரல, உடம்பு இல்லைன்னா போனது தான். Class gone is gone. No recording available. In such situation, what is the amount I should invest so that in 2025 I will be getting 1 rupee in hand as maturity value. That what amount is the present value of 1 rupee for 6 years. If I want to find it for 2024, it's present value of 1 rupee for 5 years. If I want to find it for 2023, it's present value of 1 rupee for 4 years. Similarly, for 3 years, 2 years, 1 year, 0 year. Okay, maatalama? Clear till this? Clear till this, everyone? Now, let me interchange it. What is the amount I should invest now to get that 1 rupee in future? That factor we call it as, finding that factor is present value factor. Now, I have 1 rupee. Again, I am in 2019. I am investing it at a compound interest of say 13% for 4 years. For 4 years, 2023. PS2 release on a period. What is the maturity amount I will get? I call it as future value. I call it as future value. So, this is nothing but future value factor. This is nothing but present value factor. So, ஒரே formula, two different perceptions. Present value factor is equal to 1 divided by 1 plus I, the whole power n. Similarly, future value factor is equal to 1 plus I, the whole power n. Right? If you multiply any amount this present value factor, you will get present value of that amount. If you multiply any amount or any principal value with this future value factor, you will get the terminal value or future value of A. Clear? I repeat, this time value, this compounding factor, present value factor, future value factor, whatever the name you call, in general we will call it as discounting factor. Present value discounting factor, future value discounting factor, all these comes from compound interest. This is the most important one in your intermediate, in your final, even after that. This is how the rupee dollar game plays. This is how the rupee dollar game plays. A value of share, a value of a bond, a value of security, everything depends on this formula. So even your share market, even your share market depends upon compound interest. A mathematical thing. Without mathematics, even the Indian economy can't work. Can we? I'm not joking, it's serious. Clear till this? Everyone? Now. Now, let me take years here. Let it be any amount. Let it be any investment, any type of investment. Say you are investing. You are investing. Outflow. Future value factor. Terminal value. Okay. Say you are going to invest. First year investment. Say you are investing 1000 rupees. Let me take I equal to. Suma one put over a number. So tell me a number you like. 10 to 20. Okay, 15. Let it be 15. Which means I am going to invest 1000 rupee at a compound interest factor at a portfolio which gives me a factor of a compound interest of 15% per annum. Per annum, half yearly. If it is half yearly, you know how to convert it into annual one. So what can be the future value factor? 1 plus 15%, which is 0.15 power. Say if it is for 4 years, power 5. So this 1000 will be inside the portfolio for 5 years. Clear? Clear? Now, clear? So what can be the terminal value? This factor multiplied with outflow. So if you have 1000 rupee in hand, if you invest in any portfolio for 5 years, which gives you a return of 15%, you will get 2000 at the end of just by holding an amount for few years. What is the value of that 1000 rupee? It has become 2000, more than 2000. Now, say another amount, 1200. What can be the factor here? Instead of 5, it will be 4. Clear? Now, say another amount, 900. I'm having only 900 in the 3rd year. What can be the factor? 1 plus 0.15, the whole power 3. Super. Clear? Now, say I am having even much lesser amount, 700. The compounding will be for only 2 years. The amount will be inside the portfolio for only 2 years. 1 plus 0.15 power 2. Now, say I'm having 2000 in hand. I'm having 2000 in hand. How many years it will be inside the portfolio? Only 1 year. Only 1 year. So, every investment is at the starting of the year. Every investment is at the starting of year. 1000 is at the start of first year. 1200 is at the start of second year. 900 is at the start of third year. Similarly. So, it will be 1 plus 0.15. Clear? Clear? Now, till this, it's enough. You all understood how future value works. You all understood how future value works. Clear? Yes or no? Now, what if I rearrange this? What if I rearrange this? That is, I should get 1000. I should get 1000. I should get 1200. I should get 900. I should get 700. I should get 2000. Any amount which you have invested for 5 years, which you have invested for 5 years should give 1000. What is that? It's not outflow, it's present value. It's present value. How will you find? Equal to divided by this thing or this thing. So, if you invest 497.17 at 15% for 5 years, you will get 1000 at the end of 5th year. You will get the amount of 1000 at the end of 5th year. Clear? This 1 divided by, I have calculated this 1 divided by 2.011, right? That is what I call it as present value factor. Whereas this is future value factor. Clear? Anybody not getting it? The old Bharatwaj students, the original OG Bharatwaj students. Now, division students. If I do the same thing, I will get present value. So, in one example, we have discussed how to compute future value and how to compute present value. In this itself, can we get annuity? Annuity is nothing but so pair layer recur. This is terminal value. So I am going to find future value annuity here. Instead of variable outflow, instead of different cash flows, I am investing a constant amount each year. Example, RD, recurring deposit, or SIP. I am investing a constant amount. Say every year 900. I have got, like, my terminal value got changed, right? Now, I'm just trying to find one thing. I'm just making a sum for all the years of future value factor. I'm just finding the sum for all the years of future value factor. And I'm just trying to multiply that future value factor with the investment, with the constant investment I'm making each year. I'm getting 6,978.36. Okay. I'm getting 6,978.36. Now, I'm just finding the total of this. You will get the same answer. instead of finding the terminal value by individually multiplying the future value factor, if the investment is constant, if the investment is constant in constant interval, say at the end of first year, at the end of second year, at the end of third year, at the end of fourth year, at the end of fifth year, or at the beginning of first year, beginning of second year, beginning of third year, beginning of fourth year, beginning of fifth year. If it is something like that, instead of separately multiplying and finding the total, just find the sum of all the factors. Sum of all the factors and multiply with the constant investment. And multiply it with the constant investment of 900. This sum, this 7.75 is what we call it as future value annuity factor. Here we call it as future value factor. Whereas the sum of all the factors, I call it as future value annuity factor. Clear? It's nothing but future value annuity factor. If I try to put the same thing, if I try to interpret the same thing for present value, I will get present value annuity factor. That's it. That's it. That's it. So this is annuity. Future value annuity. This is present value annuity. I will tell you what's the formula for the same. I haven't finished yet. Now I need what? 1 divided by for all the things. One divided by the compounding factor will give me present value factor. Yes or no? 1 divided by the compounding factor will give me present value factor, and sum of all the present value factor will give me present value annuity factor. So all the years I am making an investment of 800. So if I multiply this thing with 800, I will get, wait. Okay, wait. What is the amount I should get? So like, what is the investment I should make each year? What is the constant investment I should make each year to get 800? That is what we have to find here. What's the constant investment I should make? What's the constant investment I should make? What's the constant investment I should make to get 800 here? This will not be 800. All the things will not be 800 because investment is constant. Investment is constant and the final value differs. Final value will always differ. What is the constant investment is the question here. Clear? Clear? Kindly have a look here. Now, so this is what we have been discussing for 10 to 15 minutes. We have been discussing this, how to compute annuity factors. How to compute annuity factor we have discussed. Now another 5 minutes, let's complete this annuity. Another 5 minutes, let's complete this annuity. See, we had the discussion of how to compute this annuity factor, but there is also a formula to find the same annuity factor. That is, take future value annuity. You are making a constant investment. You are making a constant investment. So let me write the terminal value as what's the constant investment? 900. What is the compounding factor? The sound வந்ததுன்னா கொஞ்ச நேரத்துல switch off ஆயிடும்ல. Okay, I will give a break for 15 minutes after this. 900 multiplied with 1 plus 15 percentage. 1 plus 15 percentage power 5 plus 900 multiplied with 1 plus 15 percentage power 4 and goes on till 900 multiplied with 1 plus 15 percentage power 1. 900 is common in all the terms, so I can take it out. So it will be 900 multiplied with 1.15 power 5 plus 1.15 power 4 and goes on. It's in descending order. What if I write it in ascending order? 900 multiplied with 1.15 power 1 plus 1.15 power 2 plus and goes on till 1.15. This is in geometric progression. A term multiply.
Mic is off, sir.
இப்ப கேக்குதா? Am I?
Yes, sir.
Okay. No, I have been discussing the same thing which was there in the Excel. So I am just writing this terminal value as a linear mathematical term. 900 multiplied with 1.15 power 5 plus 900 multiplied with 1.15 power 4 and goes on. I am taking 900 as a common one. So it will be 900 whole multiplied with the sum. And the sum is nothing but sum of geometric progression terms. Terms of geometric progression. I am just making a sum of terms of the geometric progression. So what is the formula for geometric progression, which we are going to discuss few minutes later, but anyway I am giving you the answer. If r is greater than 1, the sum is a multiplied with r power n minus 1 divided by r minus 1. If r is less than 1, if the common ratio is less than 1, the sum will be a multiplied with 1 minus r power n divided by 1 minus r. Now it will be something like 900 multiplied with, what is a? 1.15. What is r? 1.15. 1.15 power n minus 1 divided by 1.15 minus 1. In general, so this is what we call it as future value annuity factor. This is what I call it as future value annuity factor. If I multiply it with 900, I will get the terminal value. So what's the formula for future value annuity factor? What's the formula for future value annuity factor? 1 plus I by I multiplied with 1 plus I the whole power n minus 1. Clear? 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 Can I proceed? Once again, we have found future value annuity factor. Similarly, how to find present value annuity factor? Present value annuity factor. How can I find? What is the constant investment I should make? I'm not going for that amount. I'm just going with the factor. 1 divided by 1 plus 15 percentage power 5 till 1 plus 1 divided by 1 plus 15 percentage power 1. I am writing it in ascending order, so it will be 1 and here it will be 5. Clear? Now what is A? This is my A and D, like A and R are the same thing. Here R is less than 1. So what is the formula for sum? A multiplied with 1 minus R power n divided by 1 minus R. Yes, what? So what is the formula for the factor? 1 by 1 plus 15 percentage. I am writing it as 1.15. I am writing it as 1.15 multiplied with 1 minus 1 by 1.15. If I take the LCM, do few magic, I will get 1.15 minus 1. It will be 0.15 divided by 1.15. Numerator, I will be getting 1 more 1 divided by 1.15. Basic mathematics. It will get cancelled. Product inside the bracket, I will get 1.15 power n minus 1 divided by 1.15 power n. So what is present value annuity factor formula? What is present value annuity factor formula?
1 by 0.1.
Give it in formula. Give it as terms. Not in fact.
1 by I.
1 by I into
1 plus I power n.
1 plus I the whole power n minus 1 divided by 1 plus I the whole power n. Clear? Clear? Instead of writing this 1 plus I here, you can write it here itself. Or if you want, you can also write it here. That's it. With this, the concept of annuity present, that is time value of money, annuity is also over. Few problems I will share it in the group before tonight. Just have a look on the problems. Those problems will be easy. If you are clear with the concept, the problems will be easy. If you are clear with the concepts, your problem will be easy. Understanding the concept is the major thing here. Clear? CMA Institute, what? Not exactly CMA Institute. There are certain banks. In all the scenario which we have discussed now, I will be making the investment now. What if I will be making the investment at the end of this year? What if I will be making the investment not exactly now, at the end of this year? There is a, like, that term is called as a different annuity. We call it as annuity immediate. Annuity immediate is the opposite meaning. Amount invested at the end. Annuity due is amount invested now itself. Clear? Clear? Same formula, we will be having a small correction for annuity due and annuity immediate. Whatever the thing which we have discussed now is annuity due. Okay? This screenshot will help you for Annuity due and Annuity immediate. This screenshot will help you for Annuity. What is for immediate? What is for due? Due is now. Paid now itself. Invested now itself. What is Annuity immediate? At the end. Clear? Clear? Take your calculators. Take your calculators. Calculator இருக்கிறவங்க. Those who are having calculators with you, take your calculator. Sir, I don't have time to remember all these formulas. I don't have time to correctly insert the formula and find the answer. I don't have confidence on myself. For sure, I will make a mistake. Oh, I'm asking you a question. Is your exam descriptive? Objective one, right? Do you exactly need this formula to find the factor? But you need this formula for intermediate and final. You need to understand this formula. You need to understand this concept. But when it comes to exam, you don't need this formula. Rather, I'm taking this Excel. I need to find 1.15 power 5. Insert 1.15. Calculator la insert 1.15. Just type on. Just type it. Into equal to. Square. Just equal to. Not into equal to. Just equal to. Cube. Another equal to power 4. Another equal to power 5. I mean, I'm just discussing future value factor. Once again, 1.15 into equal to square. Again equal to, just equal to, not into equal to. Again equal to cube. Equal to power 4. Equal to power 5. Clear? Everyone clear? This method, this calculator trick will work for calculators, for specific type of calculators. There are also specific type of calculators which won't accept these command. In that calculator, these, like whatever the calculators we are having here, the second input will be taken as fixed unless a third input is given. There are certain calculators where we need to fix the input. How to find a calculator? Type plus. Type the plus symbol 2 times. Type the plus symbol 2 times. If you get a symbol K in the display, that's a specific type of calculator where you need to fix the input function. In those scenario, 1.15, you have to press multiplication symbol twice. Instead of one time, you have to press it twice. Then the same thing, equal to. Clear? Now, we have given the equal to command 5 times, right? We have given, Aravind, please. We have given the equal to command 5 times. For each equal to output, the calculator will by default take it into a count, take it into a memory. To recall that, To recall that, you have to press GT, grand total. In few calculators, that GT option won't be available. I will come once again for those calculators. Type GT. 1.15 into equal to square cube power 4 power 5. Type GT. That's nothing but future value annuity factor. GT will give you future value annuity factor, whereas you should make sure the calculator took into account the very first 1.15, because we haven't gave equal to for the very first input. So 1 plus 15 percentage. 1 plus 15 percentage. Type it. 1 plus 15 percentage. 1.15. The calculator will display GT because it took it into account. Again into equal to square into equal to cube into equal to power 4 into equal to power 5. GT will give you the annuity factor. Clear? And the calculator work for you. Type plus 2 times press பண்ணுங்க k வருதா அப்ப வருமே. You don't have GT in your calculator. Fine, I will come. For calculators where GT is not available, for every output answer, for calculators which don't have GT function, for every output you manually take it into account. How to do it? You have m plus function. For every m plus, whatever the display number, the calculator will add it. For m minus, whatever the display function, the calculator will subtract it. So you got an answer, type m plus. Then equal to square, type m plus. Equal to cube, type m plus. Equal to power 4, type m plus. Equal to power 5, type m plus. Clear? Finally, you have to recall all the added value. Press MRC. Clear? If you want to cancel that, if you want to erase the memory, type, that is, press MRC once again. The memory will get cancelled. Clear? The same memory plus will be applicable for the K rule calculators. So future value component over. Can we come to present value component? Can I have the attention for another 2 minutes? Present value, what we have to do? 1 divided by 1 plus I. If that 1 plus I is 1.15, type 1.15. Type 1.15. I need 1.15 inverse, that is 1 by 1.15. Divided equal to. What do you get? You will get a decimal number. That decimal number will be 0.86957. That decimal number will be 0.86957. Equal to 0.75614. Equal to 0.65752. Equal to 0.57175. Equal to 0.49718. GT, you will get 3.35216. For calculators which are not having GT, the very first time you give 1.15 divided equal to, right, where you will be getting 0.86957. Where you will be getting 0.86957. The moment you get this, type memory plus. The moment you get this, again type memory plus. That is, the next equal to type memory plus. The next equal to type memory plus. The next equal to type memory plus. That's it. MS. Clear? How to find the annuity component, present value component, future value component, future value annuity component. That's it with simple interest, compound interest and annuity. I will share the sums because it's easy. Concept over. If you are thorough with the concept, sums romba simple. Clear? One sum they will ask is depreciation. A similar concept of compound interest will be adopted for depreciation. Initial value for the machinery or installed value for the machinery after 5 years of written down value method of depreciation. What can be the value? Compute it mathematically. Instead of compounding interest formula, like you have the compound interest formula something like this, right? Something like this, right? Instead of plus, it's minus. If the depreciation rate is 15%, instead of plus, replace it with minus. 1 minus 15%, 0.85. Power 1, 1 year written down value. Power 2, 2 year written down value. Power 3, 3 year written down value. Power 4, 4 year written down value. Power 5, 5 year written down value. Clear? Now the session seems to be a marathon session. The marathon sessions should be something like this only. With that, I am closing the second part. Third part we will be continuing with third part for first day. I will be continuing with APGP. Another part 12. It's already 11:20. Third part we will be continuing with APGP. Then few miscellaneous. Indices is over. Indices is over. Similarly, I will try to complete logarithm anywhere in between. Time and distance is pending. Set language next class. For 10 minutes break. Come at 11:30. Come at 11:30.